GameSci.com. GameSci.com.
How you doing? Welcome to the if control flow statement slide. Here we're going to learn about code that changes the path of a program, that controls the path that the program takes. The simplest, easiest one is known as the if control flow statement, and let's get started right away here. I've set up some variables over here on the right side of the screen. We have the variable score with a 2 in it, and we have the variable count with a 0 in it, and we'll see how this code works and interacts with these variables. If score is less than 3, well, that evaluates to 2 less than 3. That is a true statement. When the if statement is true, we will go and execute the code inside the if statement. When this is true, we execute the indented code inside the if statement. Inside the code it goes, it says print it's true, and it is true shows up on the output. Count equals count plus 1. Why does this execute? Because it's indented. Everything indented below the if statement will execute when the if statement is true. So count equals count plus 1, and you can see the variable count went up to 1. When does the if statement stop? When we lose the indent. Now, I thought about showing some code down here, but this code below the if statement, as long as it's not indented, has nothing to do with the if statement. So once we hit the end of the indented code, the if statement is over. Let's run this example again using a new value for the score variable. We'll start this all over again, and this time we will update the score variable to contain a 4. With a 4 in the score variable, this now evaluates out to 4 less than 3. 4 less than 3 is a false statement. As a false statement, we will skip the indented code. Does everyone see what's going on here? When the if statement is true, we execute the indented code. When the if statement is false, we skip past the indented code. And the next code that is not indented, the code below the if statement with no indent, that will execute after the if statement. Basically, nothing happened there. We just jumped past the code in the if and went on to the next statement. Let's start again. This time let's set score equal to 0. So this variable will be updated, and we'll try it again. With a 0 in the score variable, 0 less than 3 is very much a true statement. What happens when the if condition is true? We go inside and execute the indented code. All the indented code below the if statement will execute when the condition is true. Once again, you'll see it is true show up on the output, and because it's indented, we'll execute the next line of code, count equals count plus 1. You'll see the variable count went up to 2, telling us basically the if statement was true twice. Stop when we lose the indent. As soon as you hit some code that's not indented, that is outside the if statement, you'll go on and execute the code after the if statement that's not indented. There you have it. That's the if statement. It's pretty easy. It's sort of a binary choice. Either we're going to execute the indented code or we're going to skip. Next up is the if-else control flow statement. Now, why are these called control flow statements? Because they control the flow of the program. Computer programs would be very boring if they have to execute every single line of code. If a program had to start at line 1 and execute line 2 and 3 and 4, if it had to execute every line of code, it would be very boring. If and if-else statements allow you to choose or control the code that executes. And that's why these are called control flow statements. Set up a couple of variables. We'll have damage equal to 9. And we'll start health equal to 10. These are our variables that our code will interact with. With a 9 in the damage variable, this evaluates to if damage is greater than 5. That's a true statement. 9 greater than 5 is very much a true statement. So just like with the if statement, if the if statement is true, we will execute the indented code. And boom, there you have it. Health equals health minus 3. You'll see that the health variable went down. It started at 10. It is now at 7. We will execute the indented code. But what happens when we're done with the indented code? In the case of the if-else statement, we're going to skip the else. We're going to jump right past that else statement. The way the if-else statement works is when the if statement is true, we will execute the code in the if block and then skip the else block. That means we'll jump past the else and start executing the code below it that is not indented. Everything in Python depends on the indentation. Let's start and run this example again, but this time set damage equal to 2. So we're going to be changing this variable to a 2. With a 2 in the damage variable, our condition is now 2 greater than 5, which is a false statement. As a false statement, this is where the if-else statement is very different than the if. The false statement, the else, provides an alternative. When the condition is false, I will skip past the if block and execute the code in the else block. And here we have it. Because the condition above was false, we will execute the code in the else block. Health equals health plus 1. Our health went up from 7 to 8. What happens when the else block is done? Once you run out of indented code, you go ahead and execute any code below this that is not indented. Again, with Python, everything goes on the indentation. This code is in the if block because it's indented below the if, and that colon right there. This code is in the else block and will execute when the condition is false because it's indented under the else and its colon. Once you reach code that is not indented, you're outside the if-else statement. Let's start this again. We'll set damage equal to 13, so we'll put a 13 in the damage variable and see what happens. With a 13 in the damage variable, our condition evaluates to 13 greater than 5. That is a true statement. 13 is much greater than 5. As a true statement, what does that mean? Go inside the if block and execute the indented code inside the if block. And there you have it. Health equals health minus 3 executes. The health variable went down from 8 to 5, and we've executed the code in the if block. We've run out of indented code though, so we'll skip past the else to whatever's after the if-else statement and pick up execution after the if-else where there's code that's not indented. One more time. Let's start again with damage equal to 5. 5 is a sort of a border condition. With 5 in the damage variable, 5 greater than 5 is a false statement. 5 is not larger than 5. So this is a false statement. When the if condition is false, what do? That's what the else is for. The else is there to provide code to execute when the if statement is false. And when it's false, it will skip past the if block and go execute the else block. Health equals health plus 1 executes, and our health goes up from 5 to 6. When we run out of indented code in the else block, it's time to go ahead and execute whatever's below the if-else statement. Again, I thought about putting some code down here, but in the end I thought, well, it's not part of the if-else statement. Anything that is not indented is outside the if-else statement, and you'll pick up execution from there. We now have seen two control flow statements, an if statement, which is sort of a one-way decision. Either I'll execute the block of code or I'll skip it completely. And now we've seen the if-else, which is a two-way decision. That means there's two options for execution. When it's true, we'll execute the indented code in the if block. When it's false, we'll execute the indented code in the else block. Next up is relational operators. If and if-else statements rely very heavily on these things called conditions, which produce true-false answers. Let's look at the relational operators that produce true-false answers. We'll start with an easy one, the less than operator, and see how it works. I've only got one variable set up over here, age with the value of 19 in it. With a 19 in the age variable, 19 less than 18 is a false statement. Now again, it reads age less than 18, but there's a 19 in the variable age, so it evaluates as 19 less than 18, and that is very much a false statement. As a false statement, what does the if-else do? It executes the code in the else. Follow the arrow and let's go execute the code in the else block. We'll print out the word false on the output, and you'll see it shows up right there. and we'll continue on with the code after that. Let's look now at the less than or equal to operator. This is a relational operator. We'll update our age variable with the value 18. So age less than or equal to 18 evaluates as 18 less than or equal to 18. And that is a true statement. It's very much true. And when the if condition is true, what do? We execute the code in the if block. That's what this arrow is showing us. The true statement above indicates we'll execute the indented code below the if. And we'll print true out onto the output, and we're happy campers. Let's move on to the next relational operator. The next relational operator is the greater than operator. We want to find out if age is greater than 18. We update the age variable with the value 16. So this reads 16 greater than 18. 16 greater than 18 is a false statement. As a false statement, what do? We skip the if block and we go execute the else block. We print the value false onto the output. It shows up right there. And moving on to the next statement, now we'll look at greater than or equal to. Again, once the if-else statement is done, it will go down to the next code that is not indented and execute that. Looping back, let's go to greater than or equal to. We update the age variable with the value 20. So this reads 20 greater than or equal to 18. That is very much a true statement. As a true statement, what will we do? We will execute the code in the if block. Whenever the if condition is true, we execute the if block code. Print out the word true onto the output. And after we're done with that, what do? We skip the else. Skip past the else and continue on with the code. Now let's look at the equal to operator. It sometimes confuses beginners. This is two equal signs next to each other. That is very different than one equal sign. One equal sign says assign the value 18 to the age variable. Two equal signs means compare age and the value 18. This is a comparison or relational operator. It will compare what's in the variable to 18. Let's update the age variable with the value 17. So this now reads 17 equal to 18, and that is a false statement. 17 does not match 18. Again, two equal signs mean we're comparing 17 to 18, and that is a false statement. As a false statement, we will skip past the if block and go execute the else code. We'll print out the word false on our output, and after we're done printing the false, we will continue on with the code after the if else. Now let's look at that not equal to operator. Somewhere a long time ago in computer science, exclamation point means not. Take the opposite of it. So this is the not equal to operator. We'll update the age variable with a 21 in it. With a 21 in the age variable, when this code executes, we're reading 21 not equal to 18. And that is a true statement. As a true statement, we will follow this arrow and execute the code indented in the if block. We'll print the word true on our output. And after we print the word true on our output, what do? We skip past the else. So there you have it. There's relational operators. All relational operators basically do two things. A, they compare the relationship between two values or two variables, and then they return true or false based on that relationship. That's why they're called relational operators. Tell me how this variable relates to that value. Send back a true if it's not equal to. Send back a false if it is equal to. The else-if control flow statement. Now I know it reads ELIF, and how am I pronouncing that else-if? But it's a shortened version of else-if. We are going to do an else if something is true. This is another control flow statement in the same category as the if statement, same category as the if-else statement. This allows you to choose more options. The if statement is a one-way decision. The if-else statement is a two-way decision. And the else-if allows you to do a multi-way decision, 3, 4, 5, or more way decision. We'll set up a couple variables here. We'll start damage with the value 12. We'll start health with the value 100, and we'll evaluate this code. Well, with a 12 in the damage variable, this is 12 greater than 10. That is a true statement. If this statement is true, we will go in and execute the code in the if block. And that's what this arrow is showing us. We'll execute the code in the if block, health equals health minus 8, and the health went down to 92. Now, where you have to pay attention is what happens next. The indented code has now run, so when we hit the end of the indentation, what are we going to do? We're going to skip the whole thing. When we hit the end of this indented code, we will jump past everything else. It's kind of like an if-else statement, right? If the if executes, we skip the else. Well, what we're doing here is skipping the else. Elif, E-L-I-F, is just a specialized form of the else statement. So it behaves exactly like an else would, and we will skip the entire else because this initial damage greater than 10 was true. We'll go on, continue the code after this else if statement, and we'll restart this whole thing. And this time, let's start with damage equal to 5. So let's take that 5 and put it in the damage variable. With the value 5 in the damage variable, the initial if now evaluates as if 5 is greater than 10, and that is a false statement. 5 greater than 10 is a false statement, and it behaves exactly like you expect an if statement to behave. It will jump to the else, but this time it's a special version of the else. It's the else if statement, E-L-I-F. And the else if statement will evaluate another true-false condition. Now we're looking at damage greater than 6 implies 5 greater than 6, and that is still a false statement. Well, if an if statement is false, what do? You skip the indented if code and you go to the next else. You've got to think of each of these as an else statement because it's an else if statement. Else if damage is greater than 3 reads as 5 greater than 3, and that is now a true statement. We've reached the point where one of these statements is true. When a statement is true, what do? We execute the indented code. So we'll jump inside this and execute health equals health minus 2. The health value went down by 2. And what do now? Well, we've run out of indented code, so we'll skip past the rest of the statement. All this code in the red block skipped completely. Think of this as an if statement. When that was true, we executed the code inside the block and we skipped the else, and we're done with our else if statement. Let's rerun this code again, start damage equal to 2 and see what happens. So that 2 will end up in this variable over there. With a 2 in the damage variable, how does this evaluate? First, damage greater than 10 evaluates as 2 greater than 10, which is very much a false statement. As with all false if statements, we will skip past the if block and go to the else. This is a special form of the else statement. Else if damage is greater than 6 reads as 2 greater than 6. That is also a false statement. Since this is a false statement, it will skip past the indented code to the next else. Else if damage greater than 3 evaluates as 2 greater than 3, that is also a false statement. However, we have run out of else if statements, so if the last if is false, we will go to the else and execute the code in the else. Remember, the else here is like a catch-all. It's going to catch everything that doesn't have a true statement above it. And sure enough, the code in the else executes. All 3 ifs are false when this else code executes. And this is false. And this is false. And this is false. Only under that condition do we execute this else. And of course, health equals health minus 1. Our health variable went down by 1. Again, the else is kind of like a catch-all. If everything above me is false, I will automatically run the code in the else. And of course, our else if statement is now done. Are you getting the picture? The if statement is a one-way decision. We'll execute one block of code or skip it. The if-else statement is a two-way decision. we have two choices of code to execute. The else-if statement is a multi-way decision. We could have 3 ways, 4 ways, 5 different choices, as many as we want. And finally, that last else at the end of it is sort of the catch basin. It catches everything that doesn't evaluate to true above it. It turns out that relational operators are not the only thing that returns true or false. Logical operators also return true-false values. Therefore, they can be used in if and else-if statements to evaluate whether something is true or false and determine if a block of code should execute or not execute. We'll start with the AND logical operator, and it means exactly what the English word AND means. All true to be true. We'll start with a truth table for the AND logical operator. C1 is short for condition 1. C2 is short for condition 2. When C1, a true-false statement, and C2, a true-false statement, how does the logical operator evaluate? Well, if both inputs on both sides of the AND are true, then the AND logical operator will return true. But if any input is false, any input whatsoever to the AND logical operator is false, then the AND evaluates to false. The way I remember it is all true to be true. The only way the AND logical operator will be true is if all the inputs are true. Otherwise, it'll be false. So let's look at a simple, tiny little piece of code. If rating equals M and age greater than or equal to 17. What I'm doing here is using this AND logical operator to combine these two together to produce one true-false answer. We'll start with the rating variable containing an M and the age variable containing an 18. So rating equal M is a true statement. Now we'll look at age greater than or equal to 17 with an 18 in the age variable. 18 greater than or equal to 17 is a true statement, so both sides of the AND are true. Well, if you look up here at the truth table, what does that tell you about the overall result? All true to be true. If you AND those two values together, it'll produce a true result. Do you see it? Also notice that you have to evaluate the relational operators first before you evaluate the logical operator. The logical operator is insisting that you have true-false inputs. I need a true-false value on the left side. I need a true-false value on the right side. When I have both of those, then I can evaluate the AND logical operator. And true turns out to be a true value. So this if statement evaluates to true, which means you will execute the indented code. Let's start again with a new rating and a new age variable and see how this if statement gets evaluated. We'll start with a rating value of T and an age value of 17 and see how that affects our if statement. First of all, rating is T, so T equal to M is a false statement. Very much a false statement. Age greater than or equal to 17 is a true statement. 17 greater than or equal to 17 is true. However, since I have a single false input, guess what's going to happen? False, true evaluates to false. The overall evaluation of the AND, when you AND both of these values together, is a false result. That means this if statement evaluates to false overall, and the code indented below it will not execute. Pay attention to the truth table. AND logical operator means all true to be true. All inputs to an AND have to be true for the result to be true. If any one of the inputs is false, then the AND logical operator will return a false. The OR logical operator. Again, C1 is short for condition 1. C2 is short for condition 2. I'm going to take these two inputs, condition 1 and condition 2, OR them together and come up with an output. What will my output be? Now, the way I remember the OR logical operator is all false to be false. If the OR is going to be false, all the inputs to the OR have to be false. Again, it works just like the English language word. What does OR mean? OR means Either one can be true for the result to be true. If paid user, I'll set up a couple of variables over here. Paid user is a Boolean variable. It could contain true or false, so it provides one of the true-false values. Credits is 37. It's another input to one of these relational operators. Well, paid user contains a true, so that side of the OR is true. Credits greater than 100, 37 greater than 100 is definitely a false statement. But this is the OR logical operator. That means only one side has to be true for the result to be true. So a true value or a false value evaluates to true. If you look up here at the table, true is the first input, false is the second input, results in a true output. So the overall value of this if statement is true. Also notice the order in which I evaluated these expressions. Figured out whether paid user was true or false. Then I skipped over the OR and figured out credits greater than 100 is false. The rules of precedence say execute the relational operators before you do the logical operators. So both sides of the OR have to evaluate first, then I OR them together to get the overall result, which in this case is true. Let's run this again with new values in our variables and see how it changes. Paid user is now equal to false. Credits is now equal to 91. Let's see what happens now. Paid user is a false statement, means the left side of the OR logical operator will be false. Credits greater than 100, 91 greater than 100 is a false statement. So it turns out both sides of the OR logical operator are false. What did we know about the OR logical operator? All false to be false. If all my inputs are false to the OR logical operator, it's going to be false. So when you OR together this false with that false, you get an output of false, and this if statement evaluates the false. That means we will not be executing the code below the if. That's it for the logical operators. Now, what do logical operators and relational operators have in common? They both return true or false. How are logical operators and relational operators different? That's in the input. On relational operators, the inputs to a relational operator are numbers. You check out two numbers and return true false based on their relationship. What about logical operators? The inputs are true false values. You input a true on the left side, you input a true on the right side, and that's how you evaluate a logical operator. So both logical and relational operators return true false, but the inputs for a relational operator are numbers, and the inputs for logical operators are true false values.